All right, these are our answers to our review for the quiz. First one, we're trying to write an equation for these. So to start with, we're gonna think about what creates this kind of shape, and in this case, that's the square root function that makes this. For number 2, that would be the x squared that makes that. All right, so we'll start with like that parent graph. Then you look at kind of the key point. So in this case, this is normally at 0, 0. It's been shifted over to the right 4 and down 1. So to move it to the right 4, we would subtract 4 from this. To move it down 1, we would go minus 1 there, and that would create that graph. For number 2 here, this vertex, which normally is 0, 0, has been moved over to the right 4. So again, minus 4 to move it to the right 4. And up 2, so plus 2. But this graph's also been flipped. Normally that graph opens up. This is opening down. So we put a little negative sign right there to make it flip over. All right, so again, think about what you would have to start with as far as a parent graph, and then move it over from there. For number 3 and 4, now we have the equation. We want to know what kind of what kind of transformations would we create. So for this one, you see the negative there. That means it's been flipped over. So this is going to open the other way than it normally does. We see this minus 2. That means it's been moved right 2. And we see this plus 7. That means it's been moved up 7. Over here, you see this plus 3. That means we've been moved to the left 3 spaces. And this plus 5 means we've been moved up 5 spaces. So again, whatever those normally look like, that's what we'd have there. All right, next one wants us to graph this piecewise function, and we see that we're transitioning here at -4. So right on the -4, I'm just gonna draw a line. Now this line is not part of the graph, but it's just gonna help keep me organized here. And so for numbers that are less than -4, the graph is going to obey this function, 3/4 x plus 1. Now that function normally has a y-intercept of 1 and goes up 3 and over 4. Now, I don't want that function to exist on this side of the transition, right? I want it to exist over here. So I'm gonna actually just bring it back. So instead of going up 3 and over 4 from this point, I'm gonna go down 3 and left 4. And this gives me kind of the point that we'll be at right here. Now, another way I could have done it is just put -4 in. 3/4 of -4 is -3. -3 plus 1 is -2. You see, that's where we're at. But now I'm gonna go down 3 and over 4. So the graph's kind of going like this, a little bit off the graph, but that's what it looks like, at least from that side. Now, for the other side of -4 on here, I wanted to do -2x minus 4. Now, that graph starts at -4, goes down 2 over 1. So again, if I bring it backwards, from there, I'm going to go up 2 and over 1, up 2 and over 1, up 2 and over 1, up 2 and over 1. I get to right there, +4. And again, I could have done that by just simply putting -4 in. -2 times -4 is 8. 8 minus 4 is 4. And I get that. Notice that I have the open circle on this. That's because for that side, it wasn't equal to -4. But I have the filled in circle for this side because that's where it actually equals. Again, my slope is -2, so we're going down 2 over 1, down 2 over 1. And that's what this side of the graph looks like. So this is what that piecewise function looks like. It's this graph, 3/4 x plus 1, kind of heading towards the 1, and then this one heading down towards -4. All right, now we were given 2 graphs. We were asked to find some things, some composition. So first we want g of f of x. That means we're going to take the f function, we're going to put that into the g function. So instead of x squared, we're going to go -2x minus 3 squared and then plus 2. Now, technically, that is g of f of x. I wouldn't need you to do anything more than that. If you did want to expand this out, then you would need to take -2x minus 3 and multiply it by itself. So don't distribute the squared, multiply it out. -2x times -2x is 4x squared. You're going to get a positive 6x, another positive 6x, and then -3 times -3 would be 9. That's what this squared equals. We're adding 2 to the end of it. So if you wanted to expand it out and combine, you could also write it like that. Either one of those is correct. For number 7, we're taking g of negative 2. That means I'm going to put negative 2 into the g function. Negative 2 squared. Negative 2 times negative 2 is 4. 4 plus 2 gives me 6. So g of negative 2 is 6. Now, we're going to put 6 into the f function. Negative 2 times 6 is negative 12. Negative 12 minus 3 gives us negative 15. So start on your inside. What does that equal? And then keep working out. So we get something like this. And I want to find g of 3 first. So put 3 into the g function. 3 squared is 9. 9 plus 2 is 11. So now we'll put 11 into the f function. Put it in here. Negative 2 times 11 is negative 22. Negative 22 minus 3 is a negative 25. All right. Now we'll put that into our last function, the outermost, which is g. Put negative 25 into that. Negative 25 squared is 625. 625 plus 2 gives us 627. So you just kind of work from the inside, keep plugging them in until eventually you're done. All right, last one here, we want to find the inverse of f. A couple different ways to do that. One way is to replace the function f of x with y, and then we're actually going to switch x and y, and that creates the inverse. We're switching every x and y coordinate and doing that, and now we're going to solve for that y. So you would add 3, and we divide by negative 2. So we end up with this right here as y, which represents our inverse function. So x plus 3 divided by negative 2. So that's one way to do it, and that's certainly a fine way. That's a way a lot of people like. Another way would be to just look at your f function and say, if I were to put a number into there, what would be the steps I would take? What would I do? The first thing you would do is to multiply by negative 2. And then after you multiply by negative 2, the next thing you do is subtract 3. That's what f function does. So if we want to do the inverse, we're going to do the opposite of these things in the opposite order. So the opposite of negative 3 is plus 3, and the opposite of times negative 2 is divide by negative 2. Notice how we add 3, start, and then divide by negative 2. So it's another alternative way to do it. The choice is yours. Both work really well. All right, last page here wants us to take this function, which is a composition, and try to decompose it. So you notice that it was f of g of x. G of x is going to be the inside function here, and f is going to be the outside. So if I'm looking at sine of 5x minus 2, I see that 5x minus 2 is inside of sine. So 5x minus 2 is going to act as our inside function. Right? And what did we put 5x minus 2 into? We put it into sine x. Now you do have to have that x placeholder. You have to have somewhere for it to go. You can't just have sine by itself. But that would be one of the compositions we could make here. Okay. Then the last ones want us to write an equation. They don't want us to calculate anything or do anything fancy. Just can we write an equation to represent this? So the salary of an employee, S, varies directly. So we're going to have some constant K, and because it's directly, that means we're going to multiply. And what are we going to multiply with? The cube root. So I'm going to do a root, and it's a cube root, so we're going to put a 3 on there, of the experience of the employee. So there's our equation. Same idea here, student grade. So I'll put G is jointly dependent. So that means we're going to multiply by a couple things. One thing is the amount of hours studying, which they have H, and the square of the number of completed assignments. So completed assignments squared. And that's it. These equations are pretty simple to put through. You just have to know if I am multiplying or am I dividing, what's happening there.